Okay guys, welcome back to the IPC Flip Classroom. Once again, I'm Mr. Hawkins, and today I'm coming to you live from a new location. Today we're in my actual classroom here at Friendship High School. Today we're going to be starting the beginning of Unit 4, which is chemical reactions, okay? The first thing on the docket today is the law of conservation of mass. The law of conservation of mass is a very important law for the chemistry, as you'll come to find out through this video. It is actually one of the main laws that dominates all of chemistry. The law of conservation of mass is very vital to a lot of the processes that occur in the science of chemistry. It states that matter can't be created or destroyed, it only changes form, okay? Now, sometimes this law is known as the law of conservation of matter, okay, law of conservation of mass. Regardless, they're the same thing, okay? Remember, how much matter we have is equal to mass, all right? So if we're saying that matter is conserved, we're saying that mass is conserved also. Also, note that it can't be created or destroyed, so we can't go and just out of nowhere have water appear, okay? That doesn't work. It has to change from another form. We have to either get it from somewhere or collect it from the gas or do something like that. What the law of conservation of mass essentially says in terms of chemistry, okay, the mass of the reactants, which is what you start with in a chemical equation, will be equal to the mass of the products, which is what you end with, okay? What you start with in terms of mass will always be equal to what you end with. In a chemical equation, that holds true also, and we'll discuss that more as we get into chemical equations, all right? But for right now, understand that what you start with equals, in terms of mass, what you end with, all right? Good. Now, there's a few other vocabulary words that we need to know for this unit. The system and the surroundings are going to be important. First of all, the system is whatever we're being studied, whatever we are studying, okay? So if we're studying how baking soda and vinegar act on one another, and we have it in a bag, okay, the bag would be our system, all right? The surroundings would be everything else throughout the classroom, all right? So the classroom itself would be the surroundings, but the system would be whatever we're studying. So if we have baking soda and vinegar, okay, and we have it in that baggie, just like I said, as you can see this image right here, the bag would be the boundary between the system and the surroundings. It's what's keeping it separated. Now that can be open or closed, which is exactly what we're going to talk about now, okay? In a closed system, much like what we've done in lab, okay, if you put the baking soda and vinegar in a plastic bag and you seal that bag as tight as you can, you've cut off the system from the surroundings. So it ain't going to act with one another, all right? They're separated well by that firm boundary, okay? So make sure you understand that, all right? In a closed system, the surroundings have no contact with the system. But in an open system, that is not the case, okay? In an open system, the system has very effective contact with the surroundings, all right? They can exchange mass and other things frequently. So, for instance, if we did the same experiment, baking soda and vinegar, like we did in lab once upon a time with a beaker, right? Where we put the baking soda and vinegar into the beaker and we watched it fizz up. Well, if we do that, that's an open system because the gas is getting out and having contact with the surroundings, okay? But mass is still conserved in this, okay? Whatever mass we initially started with, whenever we go and mass it at the end, may not be equal. But you can automatically assume if it's an open system that the surroundings took it on, okay? So the surroundings got whatever came out of the initial system, okay? Does that make sense? So in a closed system, everything stays the same. Mass is completely conserved. It shouldn't change at all, okay, from beginning to end. But in an open system, you could expect the mass to fluctuate a little bit, all right? So keep that in mind. Make sure you understand the definition for the law of conservation of mass or conservation of matter, all right? Make sure you know the difference between the system and the surroundings, all right? Make sure that you know that the system's whatever we're studying and the surroundings is everything else. Okay, so keep that in mind as we go through this unit. We're going to be discussing these far more in depth in class, but these are important vocabulary words that you need to have a very firm grasp on, all right? Otherwise, if you have any other questions, post them in the comment section below or feel free to ask them during tomorrow, okay? Have a great evening, and we will see you later.